Hello everyone, welcome back to my YouTube channel. I am Manpreet Singh and you are watching Physics World. So in today's lecture we will be starting uniform circular motion under the headline circular motion. So circular motion is a very wide topic, and the problem with circular motion is that in NCRT circular motion is in discrete form. That is, it some portion is in motion in plane, some portion is in Newton's laws of motion, and some other portion is in rotational motion and work energy power. So I should suggest you that you should practice circular motion as a separate chapter. In many books available in markets, circular motion is described as a separate chapter because it has many topics, and those topics are divided into many chapters. So I would suggest you that you should read circular motion as a separate unit, as a separate chapter. So circular motion has majorly four things. First is uniform circular motion, which in NCRT it is in motion in plane, last topic. The second thing is circular dynamics, which you will study in rotational motion. The third is vertical circular motion, which is in work energy power, and the fourth is banking of road, uh, which include the in which is included in the Newton's laws of motion. So the first basic topic is uniform circular motion, and it is in the motion plane. So let's study uniform circular motion, and let's start the video. So what is uniform circular motion? You have studied uniform circular motion in class 9th also. Class 9 chapter 8 motion, last topic is uniform circular motion. So uniform circular motion means when you are traveling in a circular path, when a particle is traveling in a circular path with constant speed, not velocity. Not velocity because velocity changes as direction changes, as it is a vector quantity. So when the particle moves around the circle, it changes its direction, and thus the velocity vector also changes accordingly, but its magnitude is constant throughout the motion in uniform circular motion. And that's the main definition, and that's the main criteria for uniform circular motion. That is, and a particle who's traveling in a circular path with constant speed, or the magnitude of velocity should be constant. So let's write the statement. So this is the definition of uniform circular motion. So the definition says that if a particle moves along a circular path with a constant speed, that is, it covers equal distances along the circumference of the circle in equal intervals of time, then its motion is said to be a uniform circular motion. Simple definition, and I have explained it that in uniform circular motion the particle should always be in constant speed, not velocity. Is a vector quantity. It changes as the direction changes, and in circular motion you know that at every point the direction changes. And there are many examples of uniform circular motion. Some of them are written here. Motion of the tip of the second hand of a clock is an example. Motion of a point on the rim of the wheel rotating uniformly is also a example of uniform circular motion. So now we should study that what uniform circular motion actually means. So I should start the conversation with a question that is a very famous question of class 9th. The question says that in a merry-go-round, in a merry-go-round, in a merry-go-round, which is which is circulating with uniform speed, let's say 10 meter per second. This is a very famous question of class 9th. In a merry-go-round which is circulating with the uniform speed 10 meter per second, so there are four options given to you about the motion. First is it is a non-accelerated motion. Second is it is uniform circular motion. Third is velocity vector. Velocity does not change, vector नहीं, vector class 9th में नहीं पढ़ाते. So velocity does not change. Fourth is speed always change. Speed always change. So what's the correct option for the above question? So many of us confused it in this question, many of us, and write non-accelerated motion as the correct option because many of people see that uniform speed they रखी है 10 meter per second है, so there is no acceleration, so hence non-accelerated motion. But there is a catch in the question. This is wrong. Uniform circular motion is a correct option. Why? Because acceleration is based on velocity. Acceleration is also a vector quantity. You always need to remember this, that which quantities are vector and which are scalars. So uh, acceleration is a vector quantity, and therefore acceleration also changes as direction changes. Since velocity changes in a uniform circular motion because direction is changing, velocity or any vector has two components, one direction and one magnitude. So if any of these will change, the physical quantity will automatically change. So velocity changes due to change in direction, and hence acceleration is also changing. Uniform circular and uniform accelerate. So that's the correct option, uniform accelerated motion. In class 9th we left till here, and now we shall move forward to actually derive the formula for acceleration and the direction and all of these things. So let's move further. So this is the diagram representation of uniform circular motion. So here in this case you will understand that why uniform circular motion is an uniformly accelerated motion as well. So why it is so, let's see. So first of all you can see that here velocity vectors, this is the velocity vector at point this. Let's name this point as point A, point B, and let's assume it point O center, and this is point C. So at point A, velocity vector is towards this side, tangential to it. Yes, remember that. Remember that velocity vector at a curve point at a curve point is always tangential to that curve. Yes, tangential. Tangent. You know tangent? Yes. Tangent is basically a line that passes through only one point of a curve path. Yes, of a curve path. That is in a circle. If you draw a tangent, then the common point between the tangent and the circle is only one, and that is here is point A. Yes, that's the definition of tangent. You know it from class 10th mathematics. Yes, so velocity vector 1 passing through point A is in this direction, velocity vector 2 passing from point B is in this direction, and velocity vector 3 passing from point C is in this direction. Yes, all the directions are different. When you draw a tangent here also, this direction would be like this. So you can see that at every point direction changes, and when direction of a vector quantity changes, the whole quantity will change. Yes, the whole quantity will change, and that's why uniform circular motion is a type of accelerated motion also. Yes, it is an accelerated motion also. And how accelerated? Uniformly accelerated. Yes, non-uniform accelerated, no, uniform acceleration. Yes, uniform acceleration. Sorry for the this 1 minute. Okay, now it is fine. Now I know I don't have to move my hands here and there to catch the page. Yes. So another thing to notice is that velocity vector at a given point on a circular path and the radius, they are perpendicular to each other. Why? Very simple mathematics. Tangent is always perpendicular to what? To radius at the point of contact. This is the theorem. This is a theorem. You have studied this theorem in class 10. I think 10.1 theorem it is. In 10.1 theorem, they have stated that tangent and radius are perpendicular to each other at the point of contact. So tangent is this, radius is this, they are perpendicular. So this is also a point to be noted. MCU can be asked from this that uh, radius and velocity vector in a uniform circular motion are are perpendicular, are non-perpendicular, or what? Yes, MCU can be asked from this. Yes, so this is the diagrammatically representation of what? Of uniform circular motion. And here point to be noted also, v1 vector modulus is equals to v2 vector modulus is equals to v3 vector modulus. Why so? Because modulus means magnitude, and remember that magnitude is not changing. Velocity's magnitude gives what? Speed. Velocity's magnitude gives speed of the particle. Yes, speed of the particle. And we know that in uniform circular motion, speed is constant. Yes, speed is not changing at all. Yes, so I hope that's clear from till here. That's clear. Yes, ये यूनिफॉर्म सर्कुलर मोशन क्या होता है, यूनिफॉर्म सर्कुलर मोशन कैसे होता है, एंड उसके कुछ चीज़ें हमने सीखी. ठीक है, एक्सेलरेशन एक्सेलरेटेड होता है, वेलोसिटी एंड रेडियस परपेंडिकुलर होते हैं, एंड ऑल दैट. नाउ वी शैल मूव फॉरवर्ड टू study some terminologies of circular motion, and now we will proceed to end the lecture also. Yes, in next video we will understand about the centripetal acceleration, which is very important, and its derivation also. So now let's make a chart. Angular वर्सेस क्या? एंगुलर वर्सेस हम करेंगे लीनियर. यस, एंगुलर वर्सेस लीनियर. यस, सी, physics is not difficult at all. Physics is not difficult. What's difficult is mathematics. This is the truth. Mathematics is difficult, physics is easy, very easy. What makes physics difficult is that in class 9th and 10th, why physics is easier than 11th or 12th? Because in 9th and 10th there is no, what say, non-uniformity in the uh, physical quantities. That is, now you have to apply integration and differentiation, because the things are not constant, they are variable. That is, displacement is a function of time, velocity is a function of time, and acceleration as a function of time. These are not in class 9th and 10th, but in 11th this is there. That is physical quantities are not constant, and we have to apply calculus there. And the second thing that makes physics difficult is that angular angles, when the values change by angle, that's make a difference, that makes physics difficult. Yes, when when at 30 degree the velocity is some, when at 60 degree velocity is different, 90 degree it is totally different, 180 degree totally different. And this is brought by vectors. So vectors and calculus both are purely mathematics. Yes, both are purely mathematics, not physics. They are used in physics, they are used in physics more than mathematics, they are used in physics, although they are the topics of mathematics, but they are used in physics. Why? Because we have to deal with angles, we have to deal with the non uniformity in the physical quantities. So that means physics is not difficult, mathematics is difficult. Focus on mathematics rather than physics. फिजिक्स आ जाएगी हाथ में, मैथमेटिक्स करो, ठीक है. यस, जस्ट जोकिंग, फिजिक्स को करना ही है भाई. सो एंगुलर वर्सेस लीनियर. अब देखो, फोकस केयरफुली. All the things are same in angular and linear. डिफरेंस इज एंगुलर के आगे बस एंगुलर वर्ड लग जाता है. जैसे फॉर एग्जांपल एंगुलर डिस्प्लेसमेंट, एंगुलर वेलोसिटी, एंगुलर एक्सेलरेशन एंड ऑल, टॉर्क you will study in rotation dynamics, moment of inertia. These are all related to when the body is moving in a circular path. Yes, in a circular path, then only they come into play. Yes, these quantities come into play. Yes, so we will study these quantities thoroughly, but now you should remember these quantities, their uh, signs and their units, etc. So let's study. First is angular displacement. Yes, first is angular displacement, and this is uh, symbolized as theta. Yes, theta is angular displacement. And in linear motion, what is it? It is displacement. Yes, it is displacement. Not required to put linear there, linear displacement, no requirement. Yes, only angular you have to differentiate it, that angular displacement. Linear को आप simple लिख सकते हैं. Yes, and displacement is generally symbolized as denoted by x और s. Yes, x और s से हम इसको symbolize करते हैं. Next is angular displacement के बाद angular velocity. Angular velocity is omega. Yes, angular velocity is omega. Yes, and velocity is what? In linear motion, velocity is velocity. Yes, so angular वाले जो quantities है, they mean what? They means that when you are going through a circular path, when a particle moves in a circle, then these quantities are to be noticed. Yes, these quantities become significant. Yes, एंगुलर डिस्प्लेसमेंट मतलब उसने कितना एंगल कवर किया. एंगुलर वेलोसिटी, उसकी एंगुलर वेलोसिटी क्या थी. यस, एंगुलर वेलोसिटी when it is moving in, when it is covering an angle in a particular time, that's angular velocity. Simple as that. Not make your life stressful. Yes, make your life distressful. These terminologies are just terminologies. Their formulas and all derivation, etc., all are 98% similar to that of linear. Yes, चलिए वेलोसिटी को हम करते हैं v से रिप्रेजेंट. यस, नेक्स्ट इज एंगुलर एक्सेलरेशन. एंगुलर acceleration, acceleration, angular acceleration is denoted by alpha. Yes, angular acceleration is denoted by alpha. And there is tangential acceleration. Tangential. What is tangential acceleration? Although in uniform circular motion you don't have to need to study angular acceleration and tangential acceleration. Why? Because it is uniform circular motion. Uniform circular motion doesn't have angular acceleration and tangential acceleration, but I will tell you about these two terminologies also, because we are not dealing only uniform circular motion from motion in a plane chapter. We are discussing circular motion as a separate unit. Yes, as a separate unit, I must focus on it. Yes, and I told you in the beginning that you also have to uh, you also have to uh, realize that this is a separate unit. Yes, this is a separate unit. Yes, study this as a separate unit. Deal this topic with a separate chapter. Yes, make it as a separate chapter. Tangential acceleration, it is denoted by a t and a r. yes, ए आर भी लिख सकते हैं आप, ए टी भी लिख सकते हैं, बिल्कुल ठीक बात. देन आता है दो चीज़ें और हैं. टॉर्क, हालांकि और भी बहुत सारी हैं, बट अभी फिलहाल के इतना ठीक है. टॉर्क, torque is denoted by tau. Yes, this is tau. Torque is denoted by tau, and here it is what? It is force F. So what happens is these all physical quantities are actually a rotational analogy of these quantities. What is rotational analogy? Rotational analogy means in rotational motion, that is the dad of circular motion, we have to deal with these quantities. Yes, as reference to these quantities, we have to deal with these quantities in angular वाली cases. Angular वाले cases में ये सब quantities आ जाती हैं. Yes, and finally is what? Centripetal acceleration. Centripetal acceleration. This is the main jerk. Yes, this is the main jerk. This is not angular. Linear भी इसको नहीं कह सकते. ये बीच की चीज़ है, बट इट इज़ थोड़ा बहुत रिलेटेड टू लीनियर. यस, इसका झुकाव थोड़ा बहुत लीनियर से है. इट इज़ बेंड टूवर्ड्स द लीनियर, इट इज़ इंक्लाइन टूवर्ड्स द लीनियर, बट नॉट प्योरली लीनियर. एंड एंगुलर तो बिल्कुल नहीं है ये. सो it helps in circular motion. That's the only work of it. It helps a particle to move in a circular path. बस इतना आपको ध्यान रखना. And that's the lecture today. I hope that's clear and all the concepts are clear. In the second video we will discuss about centripetal acceleration, we will discuss about angular displacement, angular velocity, and their relationships with displacement, velocity, and etc things. So thank you, that's all for today's video.